lot of Java programs are written inefficiently, often without the programmer even knowing that the code that they're writing is inefficient, because of misconceptions or lack of understanding around strings and, in fact, around objects in particular. So we'll look at some of the examples of ways that people commonly use strings in their programs, but that are actually very inefficient in terms of the execution of the program. They're often quick to write, but they're very inefficient in terms of the computing and computation that's required for them. So one issue is often converting values into strings that later then have to be parsed out of the string, that probably would have been better to just store or to give as whatever the values are that it's most likely to be used as. And the other very, very common problem is doing string concatenation using the plus operator, which is extremely easy to write into your code, and it turns out also extremely inefficient in a lot of settings. Here's an example method called display factors that takes in an integer and finds all of the factors of that integer. Now, it combines all those factors into a string result that states, your number equals something times something times something, and shows you all of the factors as a string. And it will build that string by using the plus operator here and the plus equals operator here to put together the different pieces of it. So both of our problems are demonstrated in this code that I've shown here. That first off, these integers that might be mathematically useful, the factors that we wanted, they're turned into a string that if someone actually wants to do math with them, they're then going to have to parse them out of that string. And these are expensive operations to go back and forth between these formats here. Sometimes turning a simple type into an object and then back into the simple type is referred to as boxing, to put it into the object, and then unboxing to put it back into that simple or primitive type like we've got here, where we've boxed the integers by putting them into a string, and then we have to unbox them by turning them back into integers if we want to do math with them. And we'll see some other examples of this with other object wrappers for primitive types. The other mistake, again, is doing string concatenation in an inefficient way. So our previous one did the plus equals and the plus over and over again inside of a loop, and we will see that the better way to do this is to use a class like string builder that's made for putting together pieces of a string and eventually coming out with the whole result as a string. And here's a little bit about why. Strings in Java are immutable. We will always be making new copies of them when we do stuff to them. You may remember that function methods like toUpperCase, they don't change the original string. They return us a new string. And so often people are copying strings when they don't need to. And even more common than that, they are copying strings when they don't know they are copying those strings or making new copies of different objects for those strings. Interestingly enough, this idea of being immutable and only returning sort of new copies with slight alterations is going to be pretty common for us when we work in functional programming later. But that's not the way that Java programmers often think. They often think in terms of modifying stuff, and you can't do that with strings. So for instance, when you do a concatenation, you're not changing the original string. You're creating new objects that are combined versions of those strings. If I say S equals A plus B plus C, I'm actually creating a new string buffer, and I'm calling append on that string buffer with A, B, and C here. So that's what Java is doing in the background, is creating that buffer and combining them. But if you do this inside of a loop, for instance, then you create a string buffer the first time through the loop, and you create a string buffer the second and the third and so on. And this is copying data and creating new objects, which takes computing power. It takes time away from our program and from our users. So there are many, many instances of this string buffer being created when the better behavior is to do like we saw before, create a string builder or string buffer, and then append to it explicitly, not creating a new one each time through the loop, but just the one time. And that way we're not copying new data, we're not finding new memory spaces and allocating them for a new object over and over again inside that loop. Now here's another example of some boxing and unboxing and some misunderstanding of how objects work in Java. So let's say a student was asked to write a greatest common denominator method that takes an integer a and b and returns the greatest common denominator of a and b. They wrote a simple method here. While a is not equal to b, if a is less than b, b minus equals a, else a minus equals b, and at the end it will return a. They then also wrote some tests. They wrote one with small numbers, one with medium numbers, and one with big numbers, looking to see if the function, if the method does what it should do, and even maybe hoping to test that it does it in a reasonable amount of time. And then the instructor goes to perform their tests, and they run this one with 302, 453, coming out as 151 as their greatest common denominator, and it times out. It's extremely inefficient. And to most people looking at this method, they would have no idea as to why it's so inefficient to do this. So you might take a moment and pause and think about, especially in light of the things we were talking about with objects, what might be happening that makes this very, very inefficient. So the end reason is that it's actually converting between objects and primitives over and over and over again inside this little method here. Because when we do operations on those values, b and a, they're going to get converted into ints and then converted back to capital I integers over and over and over again, similar to how our strings made string buffers over and over. Well, to do the math, it will convert them to ints, and then it will bring them back to being integer, capital I integer objects over and over again. And this is very common for primitives to get converted back and forth between our wrapper types, like integer or number or capital D double or things like that. So the better way to do this is to explicitly convert them to primitives first. So we create the integer or the int x and y, and we get the int value from a and b, and we store those. And then we return the capital I integer value of x at the end when we're all done. So all of the math in here is getting done with primitives, not converting back and forth, not having to deal with objects at all in this repeated part of the code. And then we just turn it into the object type that we need there at the end. So the overall message is to understand when objects are being created inside of our code, like with string concatenation or with doing math to these wrapper types like integer, and to predict if we're doing that object creation over and over again, such as inside a loop that's going to be used heavily, then we should consider if we can make something like a primitive int or like a string builder or string buffer to build the result that we need. And if we need the object type at the end, turn it back to that once instead of converting them over and over or creating string builders and string buffers over and over implicitly inside of our loops. These are just some of the ways that Java programmers misunderstand the objects and the classes that are being used, and they don't recognize that there is a lot of object creation, or in the terms of turning a primitive into a wrapper type, or vice versa, there's a lot of boxing and unboxing that gets done over and over in our programs. And with simple modifications, we can avoid those performance hits and make our programs much more efficient.